Hello, Mr. Nemo here. Another installment of Nemo Academy. We have our stretching and shrinking test, or quiz, I'm sorry, our second one of the year. And of course, we're in a hurry. We only have 5 minutes, and so we got to move kind of quick. So, to start us off, we got a couple of triangles, and these triangles are similar. So, they follow all the laws, rules, whatever you want to call them, of similar triangles. So, the first thing that they may ask you on your test or quiz is the scale factor. We've been talking a lot about it. Hopefully you realize how to find it. And so if I said, what is the scale factor from triangle DEF, which is this one here, to triangle ABC, which is the big one here, how do you do that? Well, first of all, you need to find two pair of similar sides from each triangle. So that would be DF is going to be corresponds to CB. And so once you find those corresponding sides, you want to figure out the scale factor, which is the new over the original. Sometimes I say old, although it should be just original. But so if you hear me saying old, that's what I mean is original. It starts with O, so I get a little confused. Anyway, so the new triangle typically is the one that is missing some of the dimensions. So side AC over here and side AB over here, they are unknown. On our homework, we would have an X here, maybe a Y, something like that. So if we're going to follow our rules of new over old, this would be the new one. See, I just did it there. And this would be the old or original. Again, I use that back and forth, so please don't be confused. Let's do this. So when I want to make my equation, I start off with two known things. So I said, we're going to do the 12 and a 6. So we'd have new over original. So we're going to take the 12 from the new, put it here, and the 6 from the original and put it here. And then we're going to getting a fraction. We'll divide this by what number goes into both the numerator and denominator. Well, 6 goes into both of them. So then we end up getting 2 over 1, or just 2. So that is our scale factor. Okay? Now, once we have our scale factor, it's pretty easy to find the lengths of new sides. So let's try AC over here first. So we still follow our rule of new over original. So we're going to set up our equation to do the same thing. So we're going to have new over original. And the side that we're going to use, which side is that kind of corresponds with the AC? Well, I do believe it would be the side that is ED, or 8. So when we set up our equation, we have AC, which is right here, and it's going to be over the 8. Now that, as we all know, all sides, whenever we find the scale factor, they all share the same scale factor. So however I got from 12 to 6 is the same way I'm going to get from AC to 8. So when I set this up, AC over 8, right here, we know the scale factor. We know this is going to be equal to 2. And remember, whenever we read fractions, this AC over 8, it reads AC, this is divided by 8. And the answer to that problem is 2. So we're going to work backwards now because we know the answer. The answer is 2, right? Let's work backwards to find out what AC is. And what is the opposite of division? Well, it's multiply. So what is 2 times 8? Now we're working back up this way. Well, 2 times 8 is 16, isn't it? So out of all this mess we have over here, we have AC is equal to 16. And then to find side AB, over here, we're going to do the same thing, but AB corresponds to EF. So we have new over to the original, which is equal to AB over 10, and that is equal to, we already know, 2. And I'm running out of time, so I got to go kind of quick. Remember, this is division, reading down, so we got to work backwards. 2 times 10 is 20, so AB is equal to 20. Study, study, study. More videos to come.